Hey guys, we're going to look at solving inequalities today, and this should be our last lesson in this unit before we're ready to test. So we're looking at finishing this lesson today with the practice, working on a study guide in class tomorrow, and then doing some review type stuff on Thursday, and then testing all of this material on Friday. So be prepared for a test Friday on everything from algebraic expressions, so that's evaluating, simplifying, and writing algebraic expressions. Had to think about what else we did there. Solving equations, including word problems and non-word problems, and solving literal equations, so the formulas that we rearranged, and then solving inequalities. Those four things will be covered on this test that we have on Friday of this week. So today we are going to look at how to write and solve inequalities with variables on one or both sides, and then also looking at how to graph the solutions to those. So let's get into this. This is, again, mostly review. You would have done this in 8th grade. If you had me for foundations, you did this in foundations as well. So all of this should be review for you for the most part. Solving an inequality follows the exact same steps for solving an equation. So we start out by splitting the world. So we draw the line to divide it into two sides. Then we simplify. Remember, that means distributive property and like terms. And then we start to solve it with our inverses. The only thing that is different about solving an inequality compared with solving an equation is one thing that sometimes maybe comes up, and that's this. If you end up, when you're solving this inequality, and you end up having to multiply or divide by a negative number, negatives cause things to change to their opposites. So not only do you have to change the sign of whatever you are multiplying or dividing, you also have to flip the inequality symbol to be the opposite of what it was. So what that means is if you had something like negative 7x is greater than 49, and you solved that, you would solve it the same way you would solve any other equation or inequality. You would divide both sides by negative 7. But because I had to divide by a negative, 49 divided by negative 7 is negative 7. I can't give my answer as greater than anymore. I have to flip it to less than, because dividing by that negative creates the need to flip that symbol. That is the only difference in solving inequalities compared with solving equations. Let's look at some other information about this. So when we solve inequalities, we can give our answer as a range of values that fit that inequality. And that's what we typically do. So that's like us saying range of values for the solution. So, and don't write this part down, but just think about this. If I gave you this as the answer to your inequality, x is less than 4. This statement, this symbol means less than, we know that. But that answer as the solution tells me that x can be any number that is less than 4. It could be 3.9999999. It could be 2, it could be 1, it could be 0, it could be negative 100 million. Any number less than 4 fits what this inequality is saying. X is less than 4. So any number that is less than 4 would make an inequality that had this as a solution true. And so when we look at giving our answer to an inequality, it's not just like an equation where you have something like x equals 4. If your answer to your equation is x equals 4, the only possible thing x can be is 4. But in an inequality, x can be any number that is less than 4 if you end up with a solution like this. So typically the solution to an inequality represents a range of numbers that could be the answer there, or that could make that statement true, that inequality true. But sometimes you end up in a special case, like we did with equations, where your variables cancel out altogether. So if you end up with a situation where your variable becomes 0x, and so you don't have the ability to say x is less than or greater than or whatever, then you've got to look for one of those special scenarios. Now, when this happened to us with equations, we were always in a situation of either no solution or an infinite number of solutions. For inequalities, it's a little bit different. You still have an option of no solution, and you still have an option of infinite, but we really call that all real numbers instead of infinite. Okay, y'all, I got interrupted somewhere in there, so it probably sounds like I just finished a thought, and then I'm starting something random because I don't know where I was at. So anyway, but if you got to solve one of these and you end up with 0x on one side, you can't just assume that the answer is going to be infinite solutions or no solution based on what the other side says. You actually have to read the statement that's left for you. So if you end up with a statement that is false, that's how you know there's no solution. And what I mean by false is this. If you have something like 0x is less than negative 12. So we know that 0 is not less than negative 12. This is a false statement. So because that statement is false, we would say that this as a solution means this inequality has no solution. Now, if you end up with a true statement, that's the situation where it's like it's infinite, but we don't call it infinite. We call it all real numbers, because that means all numbers could be part of the solution there. So when I say a true statement, I'm talking about if you had something like 0x is greater than negative 12. Well, 0 is always bigger than negative 12. So this would be a true statement, and we would call this all real numbers. This kind of stuff only applies when your x becomes 0. So if your x is not 0, you just give the solution the way it comes out. If you end up with x is less than 5, that's just your answer. But if you end up with a 0x, you've got to decide whether the problem has no solution or the problem has an all real number solution based on how that turns out. So false statements are no solution, true statements are all real numbers. And then the other thing you need to be able to do is give your inequality or your solution in different forms. So there's technically 3 forms. There's inequality notation, there's interval notation, and there's graph. Now for Algebra 1, you only have to learn inequality notation and graphing. We're not going to look at interval notation in here. You'll do interval notation with Miss Smith when you take Algebra 2. But for inequality notation, that just means you're going to use your less than or your less than or equal to or your greater than or your greater than or equal to symbols to show the solution. Now, sometimes they'll put a little thing in front of it and it'll look like X and a line and then your actual inequality. Don't get freaked out if you see that. That's not necessary. You don't have to put this part. But sometimes they'll do that just to show that the X value in the inequality could be anything where X is less than this particular number or greater than this number or whatever the inequality says. But that's all that does, is it defines what variable they're talking about when they give the inequality over here. So don't let that freak you out. That's just another kind of notation that goes with inequality notation sometimes. The part we're mainly going to focus on is this part right here. So we're worried about really getting our symbol correct and getting the correct actual number answer there. This just happens to show up sometimes. So I wanted you to be aware of it just in case you see it. It doesn't change your answer. It's just another way of notating it. And so then we also look at graphs. So we need to be able to give our answer on a graph using a number line. So if you remember graphing inequalities, you would, on a number line, you would put a dot at whatever value you got for that solution, and then you would draw arrows in one direction or the other. So let's look at when we use what kinds of dots and things. So we're going to put a dot, and we're going to draw an arrow. Now we use an open dot to show that a number is not included. So this is what you use when you have just a less than or just a greater than symbol with no line under it to show equal to. A closed dot means something is included. And so that's when you're going to use the equal sign symbols, and you would put a closed dot on that. Now, if you have an inequality or if you have a graph with no dots and no arrows on it, that means there was no solution to that. When you have no solution, you don't put any dots, you don't put any arrows. But if you have arrows going both directions the whole way through, that means your solution is all real numbers. Otherwise, you should have a single dot with an arrow going one direction to show the range of values that could be your solution. All right. So let's look at some examples of this. So we're going to solve these by splitting the world, distributing first. So a fourth times 2x would be 1/2 x. A fourth times 12 would be 3. And then we get 3x minus 2. And then I would continue to work this the same way we did other ones when we worked in our equations. We're going to move our numbers to the right and our letters to the left. And so I'm going to do that using inverses. So where I have plus 3, I'm going to subtract 3. Where I have positive 3x, I'm going to subtract 3x. And what I do on one side, I do the exact same thing to the other. And so I end up with 1/2 minus 3x will give me negative 5/2. And then 2 minus 3 is negative 5. And so then my last step here is to divide by negative 5/2. So that means that x is going to be positive 2. Now, notice that I divided by a negative, which means I need to flip my inequality symbol. So instead of greater than or equal to, I'm going to show this less than or equal to. So I flipped it because I divided by a negative. That only applies when the negative is on the bottom. If the top number was negative but the bottom was not, I would not have to flip this. Only when you're dividing by the negative do you have to flip it. So if that's my solution, the inequality notation for that looks like x is less than or equal to 2. So on my number line, now you could number this out all the way and have like a whole bunch of little tick marks. I'm not super worried about that. If you can't find 2 on a number line, you should not be in algebra. So I'm not really worried about your ability to find that number on the number line. So what we'll do is we'll just show negative infinity on one side, positive infinity on the other. And we'll put our dot at 2. Now for this, because we have the equal to bar in our symbol here, this is less than or equal to, I'm going to need a closed dot to show that 2 is included in my solution. If it did not have that equal to bar, I would use an open circle or an open dot instead. And then my statement says x is less than or equal to 2. So I'm going to draw an arrow in the direction of all things less. So less than 2 means I need to go, I'm trying to find a line, y'all, hold on. There we go. Maybe. This might come out looking crazy, but we're going to hope for the best. So I need to go towards the left because that's where things are going to be less. Whoa, that's gigantic. Let me see if I can make that smaller. Well, I don't know about that. That looks crazy. We're going to just undo it and just draw one by hand, and it'll just be not very tidy. And y'all will have to be okay with that. So, this way. Typically, as long as you keep your letter on the left side, you can look for your symbol to tell you which way to draw your arrow. So if my letter's on the left, my symbol is going to point the way my arrow should be pointing. So this is pointing to the left, my arrow is going to the left. All right, next. All right, so for this one, same thing. We're going to solve it first with distributive property. So I get 2/3 x and 2. And then this side's already simple. So then we're going to start swapping sides. So I'm going to move my 2x over here by subtracting it. Move my 2 over here by adding it. 2/3 minus 2 be negative 4/3 x. And then I'm going to divide by negative 4/3. So again, I divided by a negative. So I need to flip that symbol. So instead of having less than, I'm going to have greater than. And 4 divided by negative 4 over 3 is going to be negative 3. So my solution is x is greater than negative 3. So if I'm going to graph that, I'm going to put a dot at negative 3. Now this time, because I don't have the equal to bar, I'm going to put a closed dot instead of an open dot. I'm going to open dot instead of a closed dot. I said that backwards. So I'm going to go negative 3, open circle. And then this says x is greater than negative 3. Notice it's pointing towards the right. So I'm going to draw my arrow towards the right to show that anything bigger than negative 3 would count. So if I'm reading this graph here, what this says is that negative 3 is not included in my solution because there's an open dot here. But anything greater than negative 3 would be included. So if I was at negative 2 or negative 1 or 0 or 1 or 2 or 3, all those numbers can be included here. Negative 3 and anything smaller would not. Okay, let's do another one. Now this is going to be one of those special cases. So let's look at how this is going to look and what we want to look for. If I was going to simplify this, I would start by combining terms because I don't have to do distributive property here. But I've got x's on, 2x's on the same side. So 2x plus x would give me 3x minus 7. And then this side is still 3x plus 10. Now if this was an equation, we could stop right there and we could say, oh, there's no solution. And we would be done. But we can't assume that there's no solution to this one until we reach the end and see whether our final statement is true or false. So to do that, we're going to subtract our 3x and add our 7, just like we would do if we were going to be able to solve this all the way. 3x minus 3x becomes 0x. 10 plus 7 is 17. Bring down my symbol. From this point, because I can't divide by 0, there's no reason to try to do that. We're going to look at this statement and see if this is true or false. So the statement says that 0 is less than 17. And 0 is less than 17. This is true. So because we have a true statement here, 0 is less than 17, we say our answer is all real numbers. Now, you can show that in inequality form. I don't think that that's going to come up. I think they're going to write all real numbers if you get that. But it could show as negative infinity to infinity with x in between. I really don't think that's going to pop up, but if you see it, that's what that actually means. It means anything from negative infinity to infinity. And our graph of this is going to look like arrows going in both directions, so that every number from negative infinity to infinity could be included. All right, moving on. All right, let's take a look at this one. So this one's already simplified on both sides. I just got to start swapping stuff. So I'm going to move the 1.76 to the right and the negative 0.19y to the left. So I'll subtract 1.76 because it's positive. That'll cancel it. And then I'm going to come over here and do the same thing. And then at the same time, I'm going to add the 0.19y. And I'm adding it because it's negative. So negative 0.19 plus 0.19 will cancel it out on that side. So I'm going to come over here and I'm going to add 0.19y. So when I add that negative 0.13, remember that this goes with it. So we do negative 0.13 plus 0.19, okay? And so when you do that, you get 0.06 y. And then 2 minus 1.76 gives you 0.24. And then our final step here is just to divide by 0.06. And so none of that was negative. I don't have to flip anything. So I'm going to still have less than or equal to, and this gives me 4. So negative infinity to infinity, 4. Do I need an open dot or a closed dot? Hopefully you just said closed. Maybe you didn't say it out loud because people think you're weird. Maybe in your brain you said closed. And we know we need closed because we've got this line here that tells me I need a closed dot. And then my arrow is going to go to the left because my sign points to the left. Everything lower than 4. So less than 4 goes left. Okay. We'll do one more together, then I'll let y'all try a couple of these. Pause the video and try a couple. So this one, distribute 5x plus 20. Combine terms over here. 5x plus 25. All right, and then we can't tell from this point whether this is going to have no solution or an all real number solution, even though we know our x's are going to cancel. So let's finish it, and then we'll take a look at what we end up with. So I'm going to subtract 5x and subtract 20. So we end up with 0x, 5, and I have this. So again, when you reach that point, if you've got a 0x, you can't finish solving this. So you look at the statement you have and decide if it's true or false. So my statement says 0 is greater than or equal to 5. 0 is not greater than or equal to 5. This is false. So because we have a false statement, our answer is no solution. Now, no solution can also be written as like an O with a line through it. That means empty set, no solution. And if there's no solution, you don't graph it. There's no way to graph no solution. So our graph would stay blank. All right, I know this one says examples, but I'd like you to go ahead and pause the video and then do this one and the next two in your notes. So this one that says examples, and then the next two that say you try it after this. 2 of these are going to be those special cases of no solution or all real numbers, and then one of them actually works to have an answer, but the answer is a fraction, so don't freak out when you get that. But pause the video right here, try that, or try those 3, and then come back and see if you were correct. Okay, so take a look at this first one. Hopefully you were able to come up with no solution as your answer. As you worked it out, you ended up with 0D is less than negative 12. And we know that 0 is not less than negative 12. That is a false statement. So we give that solution as no solution. If you missed this, go back and look at your work and compare it with mine and see if you can find where you made your mistake. In the next one, when you worked this one, you should have gotten a solution of all real numbers. And that comes from getting 0 on one side and 0 on the other. And because this says 0 is greater than or equal to 0, the equal to bar allows this to be true. So that means all numbers could be solutions to this. And so you gave all real numbers as your answer, and then a graph that goes in both directions. And then the last one. This one actually came out to be kind of a strange answer, but you end up with x is less than or equal to negative 3 over 7. You had to subtract here and get negative 7/3, and when you divided that 1 divided by negative 7/3, you get negative 3 over 7. You did have to flip your symbol, so check and see if you did that. Because you divided by a negative, you had to flip. So from greater than or equal to, change to less than or equal to. And so we graphed that with a closed dot going to the left. All right. Now we need to look at some word problems. Now, all I'm really concerned about with these word problems, I want you to be able to solve them, but I think the others were enough practice for us to be able to do that. So the main thing we're going to focus on here is being able to set these up correctly, because most of the questions that I've seen on practice materials and stuff are questions with which inequality best represents the situation, and you're picking multiple choice the inequality that would best fit the story problem or the problem that's given to you. So it's not always about solving it. Sometimes it is, but not always. It's mostly about being able to write the correct thing. So when we're looking at this, we're going to look for some of those keywords that help us to know first what symbol to use, and then we'll use that to kind of figure out the rest of what goes together. So things that'll help you know what symbol to use. You might see words like greater than or less than. That'd be real easy if it says that. You also could see things like at most, or at least, or not more than, or not less than, things like that. So we'll want to look for those and think about what they actually mean, and then put all that together in our inequality. So when we read this first one, 1/3 of a number plus 2 times the number is greater than 3 times the number minus 2. So they ask us to write an inequality to represent this and then to solve it. I'm going to start by finding that word that tells me what symbol to use. So in this, we see the word greater than. This is greater than that. So I know that I'm going to use a greater than symbol here. So start with that. Now, the stuff that comes before greater than is going to have to go on the left side, and the stuff that comes after greater than is going to have to go on the right side. So I'm going to start with this part, figure out what it's going to say mathematically, and then I'll use this part for the other side. So 1/3 of a number plus 2 times the number. So 1/3 of a number, that means 1/3 x, plus, means plus obviously, 2 times the number, 2 times x. It's going to be what my left side looks like. And then I go to the right side, 3 times the number minus 2. 3 times the number minus 2. This is the inequality that represents that statement. Now, you could take the time to solve it, and I know it tells you to solve it, but we actually didn't take the time in class to solve them because we practiced so many solving prior to this. So we're going to leave it just like that. I need you to be able to create inequalities like this on your own by reading these kinds of problems. Take a look at this one. TJ has a part-time job. He earns $9 an hour, and he makes at most $207 a week. What is the greatest number of hours he works? So again, we're going to look for those words that tell us what symbol to use. This tells me he makes at most $207 a week. At most means he makes, the most he can make is that much. So he either makes that much or he makes less than that if that's the most he can make. So if I'm going to represent this with TJ, what TJ makes has to be less than or equal to $207. Because he makes at most $207. So what he makes is either going to be that much or less. So to represent what he makes, if he makes $9 an hour, well, that's a rate. And that's all he makes. It doesn't mention anything else. So 9x. And again, I could take the time to solve that by dividing by 9 on both sides and getting a solution to this. But I'm not really worried about that at this moment. I just want us to be able to set it up. All right, this one's a little bit trickier. Avery received an 85, an 89, and a 92 on 3 tests. How many points does she need to score on her next test to have an average of at least 90? So again, I'm going to read this and find the word that tells me what operation to use. I have this word at least with 90. So So that's going to be my operation, at least 90. At least means that much or better. So greater than or equal to 90. Now, setting up the rest of this is a little bit tricky because it talks about having an average of at least 90. So you got to think about what that word average is telling you to do. An average means you have to add up all the scores you have and divide by the number of scores there. So if I add up all 4 scores, we got 3 so far. They want to know what her 4th one would be. Then I can add x plus 85 plus 89 plus 92. And then divide that by 4 to get a score. This is our inequality to represent that. Now, because we have not solved one that looks like this, we are going to take the time to solve this one. But we won't solve the rest of them. But for this one, we can. So when you see something like this and you've got all that stuff going on, first thing you want to do is combine like terms on the top of that fraction. So you can add your 85, your 89, and your 92 together. And that gives me 266. So I get x plus 266 over 4 greater than or equal to 90. Now we'll start to solve this. And so we can solve it first by canceling out the 4 that's on the bottom. Since it's being divided, we can multiply 4 to cancel it. And so that gives me 360 over here. And x plus 266 over here. And then we just subtract our 266. And we find that her score needs to be greater than or equal to 94. So again, I need you to be able to set this up, but I also want you to be able to work these out if you need to. All right, take a minute, pause this video, and I would like you to write an inequality for this situation and solve it, and then write one for the next one and solve it. So go ahead and find the inequality and then figure out the answer to the question, and then come back and check and see if you were right. Okay, so take a look at this and see if you got the same inequality and solution that I got. So the inequality is written this way because he wants to have at least $200. That means he wants to be greater than or equal to 200. That was the right side of our inequality. So since he started at 500 and was withdrawing 25 a week, I subtracted 25W from that. And so you could work it out like this. You also might could have just used some common sense on this and figured out that he could withdraw money for up to 12 weeks before he hit his minimum amount in his account. He wanted to have at least $200 by the end. So he could only do that for up to 12 weeks if he wanted to stay within that budget there. And then on the next one, you would have written 1.75 plus 0.65x is less than or equal to 10 because there's a flat rate and a per mile rate. And no more than 10 meant you needed to stay less than or equal to that. So then when you solve that one, you get this weird decimal of about 12.6923. But it doesn't say anything about her being able to pay for part of a mile. So we would round that and say she would have to stay under 12 miles to be able to afford that with the $10 that she had. Okay? So that's the end of those notes. If you will save those and then submit them, then you should be ready to do the graded practice. Y'all have a beautiful day.